Struggling with oscilloscopes? Don't panic. Master startup, setup, and signal capture in 3 minutes. Quick guide for beginners. Step 1. Connect the probe and power on the device. Grounding is critical. Always connect the probe's ground clip to the circuit under test ground line. Warning: the clip is directly connected to the scope's ground. A potential difference between the device under test and earth ground may cause equipment damage. Channel selection. Insert the probe into any designated channel, example channel 1, and power on the scope. Verify the selected channel is activated while disabling others to minimize noise interference. Probe compensation. Calibrate the probe using the oscilloscope's built-in square wave reference signal. Adjust the probe's compensation trimmer until the waveform edges are sharp and flat. This reflects standard oscilloscope calibration, but our units feature SmartCal technology. One-click probe compensation, ditch tedious adjustments. Step 2. Configure core setting. Vertical scaling. Rotate the channel's knob to set the voltage per division, for example 500 mV per division, ensuring the waveform occupies 2/3 of the screen height for optimal measurement resolution. Horizontal scaling. Rotate the time-based knob to set the time per division, for example 1 millisecond per division, ensuring the display captures 1 to 2 waveform cycles for stable triggering and measurement validity. Coupling mode. DC coupling, full signal waveform. Coupling mode, AC coupling, blocks DC components to isolate AC variations for detailed analysis. Step 3. Trigger configuration. Trigger mode, set to auto, beginner friendly, prevents blank screen. Trigger level adjustment. Rotate the trigger knob to align the indicator with the waveform's midpoint for stable display. Trigger edge selection. Choose rising edge, measure signal activation. Falling edge, detect shutdown, transients. Switch based on your test scenario. Step 4. Observe and measure signals. Waveform centering. Use the position knob to align the waveform at the screen center, avoiding edge distortion caused by display non-linearities. Auto measurements. Press the measure button for one-touch access to peak-to-peak, frequency, period, and other parameters. Advanced models add harmonic analysis capabilities. Zoom in on details. Use the zoom function to magnify specific waveform sections, enabling close observation of pulse characteristics or noise patterns. Mission accomplished. From power on to signal capture, you have mastered the core workflow in under 3 minutes. Ready to level up? Hit follow for supercharged techniques like FFT spectral analysis, math functions, and protocol decoding. Stay tuned. Next week we unlock hidden oscilloscope superpowers.